It must be in a different quadrant.
Yeah, the unified sine of b.
Sine of b is
Y.
y.
Y. Who's that? That's sine.
Opposite.
But that's opposite one is also.
What are you talking about?
No, what are you talking about?
Just to make sure our signs are right, let me go ahead and restrict our quadrants. Because there are technically two quadrants where this could be true, and there are two quadrants where that could be true. So we'll go ahead and restrict it that way. That way we all have the same answer. Alright, you guys in the back of your spirals for those that are missing. Janelle said we should just stuck them in. And then we have. So if u is in between 0 and pi over 2, what quadrant is that? If we were to actually put it in a quadrant. Good. So there's that one for you. What'd you guys label for u as his opposite?
5.
Good. 5. Because sine SOHCAHTOA is opposite over hypotenuse. So 5 is going to be the opposite. 13 is going to be the hypotenuse. Anybody do Pythagorean? What was the adjacent? 12. And all those would be positive because I said first quadrant. This could have technically also been true in the second quadrant, hence why I went ahead and restricted. This one is in the second quadrant, V. Some of your triangles might look a little funny because you would have probably drawn a first quadrant triangle, just a normal. However, we wanted to go over this direction instead, which explains the -3. Okay, this is not to scale at all. Definitely zoomed in if that's 13 and this is 3. But -3 would be the adjacent cosine. 5 would be the hypotenuse. What was the opposite for V?
4.
Okay. How did you guys use that? Yeah, Pythagorean theorem.
That's a
Well, we already used Pythagorean, that's true. We used Pythagorean to get the unknown 12 and get the unknown 4. But now how do we use all of those, or both of those triangles, to solve cosine of u minus v when we don't know u, don't know v, and we're supposed to be doing this exactly without a calculator? Well, how do I do inverse sine if I don't know this triangle from unit system? I say, well, my point isn't to find cosine, isn't to find u, isn't to find v, it's to find what it equals. And what can I plug in over here? Yeah, what is cosine of u? Look at the u triangle, and what would cosine be?
12 over 13.
Adjacent of the hypotenuse. Yeah. Solve for the cosine of u. So looking at this triangle, I know that cosine of u is equal to 12 over 13, so I'm going to substitute. I already know cosine of v because it was given. Sine of u, I already know because it was given. And sine of v, I can look at the triangle and say, well, who is sine of v?
4.
4 over 5. It's time to say, hey, I know who each of these guys is. Who they are. 12 over 13 times -3 over 5 plus sine of u was 5 over 13 times 4 over 5. Booyah. Didn't have to know the angles, didn't have to find the angles. All I had to do was use my clues, which were all possible to solve without a calculator. Mental math, 5 times 13, I think, is 65. You guys agree? -3 and 12 is -36 plus. Same common denominator because we're using both triangles. 65. 5 and 4 is 20. Does it make sense? That the cosine would be negative. Huh. What quadrant would cosine of u minus v be? According to this, it looks a lot like second quadrant. might be a little hard to see from what I've drawn. But if you were to draw a bit more precisely with a ruler using, say, centimeters as your scale, you would see a little bit easier that the V angle minus the U angle would indeed still be the second quadrant. Because the math shows us. Now, I would ask you, but I don't know if you guys could actually figure it out. One of the most common mistakes for kids to make on this problem, if they even figure out the triangles and then the filling in, even after we do it in class, I'm talking about like on a test. One of the most common mistakes I see is that when they look at the triangle, when they find the cosine, they plug the 12/13ths in for the u, and then they take cosine of that with a calculator. That defeats the whole purpose. The 12/13, the adjacent over that hypotenuse, is the cosine, takes the place of the cosine, substitutes out the cosines entirely. So all you get left with is a fraction. So, just a quick little common mistake. Can anyone raise their hand and verbalize why I had to tell you these quadrants again? For you to get the sign correctly too? David, what are you thinking?
Because it was positive or negative.
Yeah. Good. And without the quadrants, sign could be positive in what two quadrants? First or second, yeah. So you wouldn't have known exactly which one to do, so you wouldn't have known whether to make the cosine positive or negative unless I told you which one to look at. They might give you a picture in the book, but they might give you restrictions, kind of like I did. Okay. How about this one? Wait. What are we doing in this entire section? Go to your notes. Let's leave our notes down. Good job on that. That's a great problem to look at, maybe for the quiz or a test. We can talk about that soon. We're very close to the end of chapter 5. We look at our calendar before we leave today. I think we have 5-4 and 5-5 and we're done. So let's review really quickly. Where are we in section 5-4? What's the title of 5-4?
Sum and difference formulas.
Oh, that's right. And the sum or differences are going on inside the trig, right?
Yeah.
So we have a variable like an x or a u or a theta or a who knows, somebody. We have a variable inside, but we also have something being added or subtracted to that something. And question, can sin distribute? Is it that easy? No, which is why we have to use the formulas. I'm just reminding you guys. Which is why we have to use those formulas from the beginning of section 5.4. Now, do you guys remember on Friday I was saying that you need to study those formulas along with the others that we've already talked about? Just so that we don't run out of time and I do this really fast and then some people miss what's going on. Let's go ahead and, after you write down this problem, and go ahead and show you guys the calendar. I started warning you guys on Friday about how you need to be studying the formulas, and now we have new formulas to study. You could look ahead and find the formulas from 5.5 that you also need to study. And the reason is because in chapter 5, to do the problems, you need the formulas. So if I need to test you on your abilities in chapter 5, I need to not only test whether you can do the problems with the formulas, but also whether you can know the formulas. Now, to test that all at once on one test would be, to be honest, kind of brutal. It's like, here's a problem. If you don't know the formula, too bad. It's a little rough. So instead, what I pretty much always do with chapter 5 with both honors and regular is split the test into two parts. One part is going to be formulas, and I think I kind of introduced this on Friday. One part is going to be formulas on one day, part of the day of the review, and the other part is going to be problems. Okay, kiddos, we're finishing 5.4, hopefully starting 5.5. Tomorrow we're going to be finishing 5.5, which are just some extra formulas, playing with how to use them, but using them in the same things that we've been doing all chapter, solving equations, t-proofs, simplifying stuff. We're going to be having a work day on Wednesday. Formulas. You guys see what's on Thursday? Formula part is on Thursday. Formula part is, it's one page, one side. I give you the name, the category, like for instance, reciprocal properties or reciprocal identities, and I give you, probably not all of them, So maybe I give you cosecant equals, tangent equals with a theta or with a u or with an x. And I put in equals and it's blank. You have to fill in the formula. Okay, that's on Thursday. Just fill in, straight memorization. No T-proofs, no problems, no unit circle, no calculator. Just you filling in formulas. That's on Thursday. And the reason I did that on Thursday, number one, when you finish, we can be working on the review, working in groups on questions, etc., etc. But on Friday, guess what I'm going to have copied off for you that you can use on the problems? All the formulas. All the formulas. Specifically the really, really hard ones. I might not give you, well, I'll probably give you almost all of them. So I'll give you the formulas because I tested your knowledge on the formulas on Thursday. That way I can give you the problems with the formulas on Friday so I can see whether or not you can do the problems, not whether or not you know the formulas. Because if you mess up the formula just a little bit, the problem would be all wrong even if you did it right. So that's what's coming up at the end of this week. Our goal is to finish 5-4 today. Hopefully we'll get into 5, oh that's not you guys, hopefully get into 5-5 so you can see what formulas from 5-5 you need to memorize because so far you need to memorize all the formulas all the way back to section 5-1. Like the Pythagoreans and the quotients and the reciprocals, we've been using them over and over again. Now we've added the sum and difference ones, you need to know all of those, but in 5-5 I don't make you memorize them all for Thursday. So I'll kind of help you out by showing you which ones to memorize. Let's keep doing examples though. We have 1, 2, 3. Okay. 3 more examples. Here we go. 61. What do the directions say?
Prove.
Ooh, prove. So what are we going to do right away whenever we see prove or verify? Draw a T. Okay, it's a really awkward T, but it's okay. Draw a T. It's a T proof. What do you guys see? Left side or right side is more complicated. You're right. See, not everything's hard. Okay. Left side, rewrite. I'll just point on something silly like not setting it up right. Let's see how many of you guys studied your formulas because right now there is nothing to do except use formulas. This one you could use sum or difference. This one you could use sum and difference or what were they called? Complementary cofunction? Section 5-1. I think there was a way of naming this whenever there was a cofunction. Or you can use a cofunction property. So let's start with sum or difference, just because it's the section that we're in. Cosine of u minus v. Remember how it goes? How do you remember it? Cosine, co, with, or together. Which means, start with co. With or together, he's with the other cosine. Ooh, cosine, sine change. So plus. Good. And then who else do I need? Sine time. Nice. Could we do the same exact idea with sine, except not with or together? So it'd be sine u, sine u, cosine v. Sine stays the same, plus cosine u, sine v? Yes. But did anybody find the cofunction property from section 5-1, the table at the very beginning of the chapter? Sine of pi over 2, is it plus theta or minus theta?
Minus.
Oh, can't use the cofunction there. Bummer. Alright, so we gotta use sum and difference one. Alright, how does it go for a sine?
Sine of u, cosine
So sine pi over 2, cosine, remember not with or together. So sine is going to be with cosine, and then sine stay the same, good, plus. Flip it.
u.
Okay, that's all one big old line. I know I had to put it on 2. What do you do?
You just careful. We put the angles and stuff like that. So like cosine of pi.
We know pi's and pi's over 2's. So even though we can't simplify cosine of theta, we can simplify cosine of pi. What's cosine of pi going to be?
1.
Cosine is x, pi is over here, so negative 1. Because it's going left one. How about sine of pi?
0.
Oh, that's nice. Isn't that whole thing become 0 now? 0 times anything is 0. How about sine of pi over 2?
1.
That's going to be a 1. And how about cosine of pi over 2?
0.
Okay. So cosine times negative 1 is negative cosine. 0 times anything is 0. Cosine times 1 is cosine. Anything times 0 is 0.
Got it.
Dun, 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 dun. Dun, 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 dun.
All right.
What did this mean? The sum and difference formulas and the unit circle. Done. Cool? Questions? How do we know it was a T-proof? It says prove, which means always true. Show me it's always true. If it says solve, it's only sometimes true. Find the angles. That works. So how about this one? Ooh. Is this an always true, make a T? Or is this find the sometimes true when it happens?
Sometimes.
Struggle. Alright, there's our interval, 0 to 2 pi. We're not just solving for 1. We're not having to worry about pi ends or 2 pi ends. You have to break it down and then figure out how many angles work in between 0 and 2 pi. The question, how do we get x alone? How do we even get sine alone? Let's subtract 1. I'm not sure he's our biggest problem though, you know what I mean? Yeah, we need to somehow do this guy. And if you're thinking that, stop distributing sin. So sad. Sine, with or together?
No.
So who the sine went? The other guy. Sine, the sine stay the same. Now flip it, cosine x. Sine. Some of you already have over half the formulas for sum and difference memorized. Good job. Minus sine of x plus 1 equals 0. Now what?
Cosine pi and sine pi.
Oh yeah, pi we can do. So what is cosine pi?
-1.
What's sine pi? So we have negative sine plus 0 minus sine plus 1 equals 0. And see negative 2 sine of x. I agree, Jonathan, let's move the 1. Why not, right? Guess we could have done it earlier. I wasn't sure if we need to factor or not. That's why I kind of left it where it was. But no squared, so no factoring.
1/2.
Sine equals 1/2, and my question to you is, when will sine be a positive 1/2? First of all, what quadrants?
First and second.
First and second. Sine is the opposite, it's only up a little.
So pi over 6.
Well, my cheater chart people, 1, 2, 3, 1, that's a 30-degree. Who is? Pi over 6 and 5 pi over 6. So some of you need to study your unit circle before Friday.
Yes.
Yes. Do you need to for Thursday for the formulas?
No.
But for Friday?
No.
How are we doing? Do you see the difference between the directions of this one? Find all solutions that work versus prove. T-proof versus solve for the ones that... Oh, hey, we're done. Let me see what's this. That's just more practice. I think we went through each of those. Let's get to section 5.5. Here's what I want you guys to do, just for sake of time. Actually, let me help you in it. Let me go ahead, for sake of time. Let me get for you guys all the formulas, and let's write all of the formulas at the very beginning of 5.5, okay? We'll do all the examples later and under. You don't have to skip space for examples. We'll just do all the formulas first. So let me go ahead and freeze the screen and let you guys get these, and then let me go find the other formulas, because I want to show you which ones you need to be studying, because you don't need to be studying them all. So let me make it a little bit bigger. That didn't work. Sorry, lo siento. There we go. Okay, freeze. Don't skip any lines. Let me go find the other formulas for you so you can write them all at once. Then we'll just start playing with formulas, with examples today. And we'll keep playing with more examples tomorrow. But that way, if you guys want to make a formula sheet to be studying, or formula cards, or a Quizlet, or anything else, you can do that now, even though we might not get to examples of every single type of formula. Is there one more? Okay. Anyway, okay, there's a lot up there, right? Okay. You don't need to memorize all of them.
Just the first four.
First four, there's only four. Clever.
I can't see.
The nice thing is the power reducing one, you can kind of get the tangent squared from the other two. Technically, half angle, you can get tangent from the other two. Like there's some relationships. I'm going to put an X by this one just so that you know I didn't just forget to put a star. That doesn't sound great. You're going to think that's a star, but it's not.
Put the start date in a circle. Wait.
I'll just not put anything. You don't need to memorize the power of the sun. You're going to maybe need to use them in homework. Or maybe need to use it on like a problem, but you're going to have the formula on the sheet or the formula in your notes to use. And the half angle. And I'll do this. If he shows up, he'll be a bonus. How about that? If he shows up, he'll be a bonus.
This is absolutely.
I know, wasn't it super nice to tell you he might be the bonus?
It's tricky. This is like science squared of you, but with the old like
Can be rewritten in
science
terms
squared
of.
of 1 minus cosine.
Yeah.
I'm scared of the test.
But hold on, the sum and difference ones, well, section 5.1, we've been studying those formulas since before finals. Hold on. The sum and difference, were technically 6 different formulas, and you guys know 4 of them just by using them, I think. And little tricks like co is with or together, sine and sine stay the same, cosine and sines change. Tangent you kind of have to memorize, but we had a trick for the sines of tangent also. You don't actually have to memorize a half angle unless you want to go above and beyond and get a bonus. If it's there, which it probably will be. So all you have are these two. And if you notice, sine squared of u and cosine squared of u, tangent squared is the one over the other. The 2's cancel and the other 2 parts cancel. The other two parts, you got numerator and denominator. Now, the double angle, that's where you should probably focus some of your time studying. But, that's why I'm telling you on Monday, I'm having you write all the formulas now. Did you know what you missed is that we finished 2 examples from 5-4? It's on the video. 5-5, we're starting. These are all the formulas from all of 5-5. I went and copied and pasted, and everyone's writing them down. We're starting 5-5 today, finishing tomorrow. For the formula portion of the test, which is Thursday, you only have to memorize these 2 along with the other formulas from the chapter. That, if it shows up, will be in a bonus. And those you don't have to memorize at all. Yeah.
That's good.
Yeah. You can come up here if you want. Now, just curious, can you guys just raise your hand as far as how you have ever memorized facts before? How many of you guys just read over it lots of times? How many of you guys like saying it out loud? Like that helps if you say it out loud over and over again? A couple. How many of you guys use flashcards? Like flip them, flashcards? Either electronic or paper version. How many of you guys use paper flashcards? Like you still make them, write it out? How many of you guys use electronic? You type it out? And then, okay. You technically take pictures of the formulas from my notes if you want. You can, like, on most of those online flashcards you can, or even Quizlet, you can like copy and paste. That's an idea if you want to do that. How many of you guys use it over and over again? It kind of just ends up memorized.
We did acronyms last
Acronyms.
for bio. We had the for
That's a really good
We
idea.
had one. What was it? Something about like taking somebody to dinner or something.
What?
Clyde, it was like Clyde something. Yeah, we had a
That was
bunch
a
of
good one.
ions,
Yeah,
so we just like we gave them paper.
Wait, was
that? Yeah,
That's the.
it was something. It was like Clyde's Riley. I remember that one.
It's like,
I remember one for ecology.
It was Clyde Riley. I don't remember the first part.
They did this experiment once on an SAT.
No, something.
oh, yeah.
Because she's like, oh yeah, you have a test on this tomorrow. Like, oh crap. Then we like came up with it like during
Like a
passing
story,
period.
I
Yeah.
know, I was doing
And
that.
then we used it on the test.
That wasn't really a class. Because
Was it really? Don't say that.
we all.
No, but there's totally ways to come up with memorizing. For instance, I had this in high school. We didn't do like a pre-PSAT, pre-SAT. We did like a standardized test, kind of like middle school, but harder. I think they're called the Stanford Achievement Test, SAT, but not the other one. But this one year they were experimenting with the sections. Anybody ever played Balderdash?
What?
Oh, that's it. Never mind. If you play Balderdash, this might kind of make sense. But they gave random words. They might have not even been real words. Random words with random definitions. Like it wasn't even true. But they gave a list of random words with random definitions and gave us 10 minutes to study them, I think. 10 minutes to study them. But so we would have had no past knowledge of these words in any way, shape, or form. And they were just testing our ability to memorize. So then what do? If you have 10 minutes to memorize words, you have absolutely no idea what they are because they're not even real words with definitions that aren't even true. You have to come up with some sort of way of memorizing facts, right? Yeah, I totally did stories and all these different things. And like,
Connect one of the words with that definition.
yeah, exactly. So, the same idea here. And the nice thing was it wasn't fill in the blank, it was matching, and that made it a lot easier. But anyway, however your brain memorizes, some of you need a lot more than 10 minutes. You've got to start. Okay? We're going to play with these formulas.
Do you not get caught into some?
You don't need to memorize them, but you might need to use it. Does that make sense? So write it in your notes, have it, but just don't highlight it as far as, like, don't make flashcards for it, don't stress about figuring out some sort of trick or way of memorizing, etc., etc. The nice thing is the double angle formulas, all of them have 2's in them, whether they're squareds or whether they're actually in the formula themselves, but they're in very different places. Definitely need to study that. But can I at least show you a trick for the cosine 2u? There are 3 different versions, and I could ask you for 1 or 2 or all 3 of the different versions. Can anybody figure out, from the double angle of cosine formula, double angle, cosine, how are all 3 of these related? Which one can we start with?
The first one.
the first one, and say, wait a minute, what if I was to get rid of sine squared? It's a baby t proof. How could you get rid of sine squared?
Cosines.
Close. Not equal to cosine squared. 1 minus cosine squared. What would be cosine squared minus 1 minus cosine squared? Ooh, that'd be cosine squared minus 1 plus cosine squared. That'd be 2 cosine squared minus 1. A quick little transformation with the Pythagorean you can get here. And guess how this one comes about? Get rid of the,
Cosine.
and plug in 1 minus sine squared. 1 minus sine squared is 1 minus 2 sine squared. So you're going to do 2 little baby t proofs so you can actually get the other
There's the
2.
first one.
So you end up with cosine 2u. So we alter.
So if you were to replace sine squared with 1 minus cosine squared, distribute the negative, it'd be minus 1 plus cosine squared. So 1 plus 1 is 2. That makes sense. So you could just memorize them. But on this one especially, the bottom two come from the top one. This one, you're getting rid of sine squared with 1 minus cosine squared. This one, you're getting rid of cosine squared, 1 minus sine squared. Anyways, but you just kind of basically gotta memorize him. Sadly, gotta memorize him. Maybe you can come up with a story, maybe you can come up with some sort of trick. And I'll be asking tomorrow and Wednesday and Thursdays, because if you come up with a cool trick that I can use year after year, that'd be awesome. But no one really has come up with ones that they've shared anyway. So think about it. We'll see if you guys can find any creative ways of memorizing. You're creative. I hear you talking every day. All right. Do you need to write this down again? No.
No.
What do you need to write down?
Yes.
Let's play with it. Solve multiple angle. Okay, whatever. Directions. Solve. Find the specific ones. Not prove. Not a T proof. How do you get x alone?
I don't know, look at the whole chart.
Sine.
The whole chart, except this one looks a lot like double angle. What can I substitute sine of 2x for?
2 sine x.
2 sine, and this one is x, cosine is x. How on earth did that just make life better?
Factor it out.
Yeah. Go team. It's a lot more possible than it was a second ago. You guys see what we're doing now, right? 2 factors equal to 0. How do we solve mathematically?
1, I think the most one.
You guys able to jump and say this one's eventually, hey, make cosine 0? And this one, jump, hey, make sine negative 1? You okay? So both equal to 0. This one, divide both sides by 2, goes away. This one, subtract the 1, there we go. We're looking only between 0 and negative pi, 0 and positive pi. Cosine, x value is 0 at, and?
5.
Yeah. So that would be x equals plus or minus pi over 2. And I have to write it that way because of my interval, right? Up pi over 2, down pi over 2. When is sine or the y value negative 1?
Pi.
Yeah, it'd be 3 pi over 2, but I can't write it that way, so it'd have to be negative pi over 2. Wait a minute. Are they rewritten? Or is one doubled up? So I don't write it twice, I say whatever, negative pi over 2, even though it works in both. He's still one of my answers. So cosine or the x are zeros in both. Sine is negative 1 in one of them, but whatever, they're all options. They would all make zeros when plugged in. So guess what else we have for basically the rest of the section? Yeah, it's just examples where you play with stuff. Wait a minute, stink-a-dink, what do we do with this kind of one where they give me a sign and then they tell me, hey, there's a u, you don't know who u is, you're not allowed to use a calculator, now all of a sudden plug into other stuff. What are we going to do? Triangle! Got it. What quadrant?
Whoops.
Oh, good.
4.
4.
Ah.
Careful.
Got it.
Can I plug in a negative 3? Can I plug in a 5 and pretty quickly find a 4 with the Pythagorean? It's like the one that we did in the back of our spiral class. So how do we do 2u? If this is u, who's 2u? I don't know. Whew, good thing we have the formula. So what I've done so far is I've written out each of the double angle formulas. If you want to check it out, I've written out each of the double angle formulas.
You good, Andrew?
Huh?
You good?
Oh, you just adjusted viewers, so I was really confused.
I know you were lost on this.
Most people are confused with this. Anyway, so. Can't we just take our triangle and say, well, to find 2u, I plug in the one for u? Sine of u would be negative 3/5. I already knew that, but I needed the triangle to find cosine of u. Perfect. All the trig is gone because I plugged in opposites over hypotenuses and adjacents over hypotenuses. 5/5 is 25. 2 and 4 is 8. Negative 3 is negative 24. Then to run that. Goal! Finish 5/4. Study formulas.
What is this?
You want to be a huge overachiever, I guess. Start 5/5. But finish 5/4. Study formulas. Bye, guys. Finish 5/4. Study formulas.